Hi, in today's lesson, we're going to talk about the quotient rule. And remember, quotient is the answer to a division problem. So in all of these problems, you're going to have two exponential expressions that are being divided by one another. So let's dive right in. So our first problem has been done for us. So we have the quotient 2 to the third power, or 2 cubed, divided by 2 squared, or 2 to the second power. So if we expand this using that repeated multiplication, 2 cubed is 2 times 2 times 2, and 2 squared is just 2 times 2. So they've expanded it out. Now in the next line they did the canceling. So what you'll notice here, so for every 2 on the top, you can cancel it out with a 2 on the bottom. So those 2's will cancel, and this pair of 2's will also cancel, leaving us with just 1 2, which is 2 to the first power. Now, let's try another example of our own. So the next one is 3 to the 7th power divided by 3 to the 4th power. So if I expand it out using repeated multiplication, 3 to the 7th power is going to be 7 3's being multiplied together. So there's 1, 2, 3, 4, 5, 6, and 7. And I do want to remind you that you do need to have this information written down. Over 3 to the 4th power. So 3 to the 4th power is going to be 4 3's being multiplied together. 1, 2, 3, 4. Now the next box has us cancel out, but I'm actually going to do it right here because that'll be much simpler. So every 3 on the top in the numerator will cancel out with a 3 in the bottom, or the denominator. So for example, there's a pair of 3's that I can eliminate. I'm going to just change colors so you can see the different pairs. There's another pair. How about there's a pair. And then there's a pair. There are no other pairs of 3's that I'm going to be able to eliminate here. So I'm going to move right along. So I'm left with 3 3's. Do you guys see that? These 3 3's right here being multiplied together. So that is going to be 3 cubed, or 3 to the 3rd power. So 3 to the 7th power divided by 3 to the 4th power is 3 cubed. Let's try another problem. So the next one, we've got x to the 10th divided by x to the 4th power. Now this time those exponents, or those bases, are variables. They're x's, but we're still going to solve it the same way. So I'm going to expand out x to the 10th power, which means I'm going to have 10 x's being multiplied together. 1, 2, 3, 10. Okay, and then x to the 4th means I'm going to have 4 x's being multiplied together. 1, 2, 3, 4. Okay, and now I'm going to cancel out as many as I can. So for every x in the numerator, I can cancel it out with an x in the denominator. So those would cancel out, and by cancel out, I mean they make a 1. Then these would cancel. There's another pair, and then there's another pair. So all the x's on the bottom have canceled out, so that I need to stop. There's nothing else I can do. So this is what I'm left with. And I have 1, 2, 3, 4, 5, 6 x's being multiplied together. So that's going to be equivalent to x to the 6th power. Now, obviously, we're looking for patterns here, because when you look at the very next example, there's too much going on there. So what's happening here? What's a shortcut? Because you're not going to want to do this repeated multiplication every time. So just like in the previous exponent properties, there's a rule or a trick that you may notice. So I'm going to look at these exponents here, and then I'm going to compare it to this. So when I had 2 cubed divided by 2 squared, I was left with 2 to the 1st power. Here I've got 3 to the 7th divided by 3 to the 4th, and that leaves me with 3 cubed, or 3 to the 3rd power. Here the exponents are 10 and 4, and look at this exponent, it's a 6. So maybe I hope that what you are noticing here is that if you subtract the exponents, you should notice, and when I say subtract them, I mean the top one minus the bottom one. When you subtract it, you'll notice that they're the same. For example, the exponent of 3 minus the exponent of 2 is the exponent of 1, and there it is. Here, the exponents were 7 and 4. When I subtract 7 minus 4, I get 3. Notice his exponent is a 3. Here, the exponents are 10 and 4. 10 minus 4 is 6. Notice this guy has an exponent of 6. So maybe what you're noticing here when we do this, so you have two things here, two separate things going on. You've got 5 to the 12th, y to the 20th, divided by 5 to the 7th, y to the 8th. Well, let's just look at the 5s first. So if I subtract those exponents, 12 minus 7 is 5. So that should be 5 to the 5th. And then for the y's, if I do 20 minus 8, I get 12. So that's going to be 5 to the 5th power y to the 12th when that's simplified out. So what's the general rule that we're talking about here? So remember, in the product rule, we said we kept the base and added the exponents. Well, in the quotient rule, we're also going to keep the base, but we're not going to add the exponents. We're going to subtract the exponents. So I'm going to write keep the base and subtract the exponents. Now, we need to be a little bit clear here when we say subtract the exponents, because it does matter the order in which you subtract two numbers. So it's always the top exponent minus the bottom. So I'm going to come over here and I'm going to write in parentheses top minus the bottom. Okay? So how do I write this as an algebraic rule? So if you were to look up the quotient rule, what might you see? Well, first you would see something with variables. So I'm going to use my variable x. So some number to some power. So some number, so x represents some number and m represents whatever that exponent is, divided by that same number, so x, but maybe to a different exponent. So x to the m divided by x to the n. So notice I have the same base of x, but I have different exponents. It's the quotient rule because this line right here, remember, means division. And what did we say to do? Keep the base. So that base is an x, and to subtract the exponents. But when we subtract them, we're going to do the top exponent, which is m, minus the bottom exponent, which is n. This is our rule. This is really important, and we're going to use this. Okay, so let me do just a couple more examples down here at the bottom, because sometimes we end up with negatives, right? So let's suppose I have 5 to the negative 6th power divided by 5 to the 3rd power. So how would I solve this? Well, I'm going to keep my base of 5, and then I'm going to subtract the exponents. Remember, we said top minus bottom. So that would be negative 6 minus 3. Well, negative 6 minus 3 is negative 9, so I end up with 5 to the negative 9th power. Now, remember, with that negative exponent rule, we know that 5 to the negative 9th power is the same as 1 over 5 to the 9th. So that would be my final answer, 1 over 5 to the 9th. What if I had something different? What if I had 4 to the 16th power divided by 4 squared? How would I solve that? Well, I keep my base, which is 4, and then I subtract my exponents, top minus bottom. So the top exponent is 16, minus my bottom exponent is 2, and 16 minus 2 is 14. So I end up with 4 to the 14th power. And I don't need to rewrite that because I didn't end up with a negative exponent in my answer. So that's it for this particular lesson on the quotient rule. So now you're ready to go through and complete the independent practice for this. Before you submit this assignment, please review the assignment and make sure that your paper looks like mine. Make sure that your work is complete so that way you don't have to go back and redo anything. When you get ready to do the independent practice, before you submit it, look at the answer key and check and see if you're getting the answers correct or not. And if you're getting them correct, give yourself a check. If you're not getting them correct, give yourself an X, and then next to the wrong answer, write down what the correct answer should be. Take the time to decide if you or to figure out, did you understand why you missed it? If not, then make a note so that you can ask your teacher during your Zoom sessions or in class or via email, however you need to communicate. If you do understand where you made your mistake, then good job. You're on the way to fully understanding. Good luck.